So I'm going to go through with you one way that I do these speed quizzes. We have 10 minutes to do 20 of these trig problems. And you could choose to draw the entire unit circle, but I don't think that you have to. You can start off drawing the entire unit circle with all of the angles and all of the coordinates, and it'll take you probably 5 minutes to do all of that, but then you will be able to get through the problems usually. But I want to show you this. Let's just draw some of the coordinates. So I'm drawing the ones at 0, pi over 2, pi, and 3 pi over 2. And those are just 1 unit away from the center. And then we have these 3 special right triangle angles, pi over 6, pi over 4, pi over 3. If it helps you, you can write the degrees too, 30, 45, 60. You need to know the first ordered pair for sure. At pi over 6, we've got radical 3 over 2, 1/2. And remember, this represents cosine and sine. Pi over 3 is just flipping those points, 1/2, radical 3 over 2. And pi over 4 is easy to remember. It's the same coordinate, radical 2 over 2 for both the x and the y. All right, so when I go around this, cosine of 2 pi, I can make a note that cosine is the x coordinate at 2 pi, which is right here. So that answer is 1. Tangent is y over x. So go to 180 degrees. The y is 0. The x is -1. So this is 0. Cosecant is 1 over y. And this is an angle I don't have listed on here. So 240. I might want to place where 240 is. Remember, 210 is this one. So 240 is the 60-degree angle. So what I'm really thinking about is like, okay, what's sine of 60? So let's start there. It's radical 3 over 2. And then flip that. So 2 over radical 3. And then also, should this be positive or negative? Remember, this positive signs are like all 3 are positive in quadrant 1. Sine is positive in quadrant 2. All students take calculus. Only tangent is positive and cotangent is positive in 3 and 4 respectively. So cosecant in quadrant 3 is negative. And then finally, we need to rationalize our answer. So you do need to have simplified answers, rationalized answers for all of these. Cosine of 45, that's the x coordinate at 45 degrees, radical 2 over 2. Sine of 4 pi over 3. I think when the angles are in radians, it's easier because you can just look at the denominator to see which angle should you be using. So think sine of pi over 3. Figure out that number. That's radical 3 over 2. And then should this be positive or negative? Well, 4 pi over 3 is down here in quadrant 3, and sine is negative down there. Secant is the reciprocal of cosine, so it's going to be 1 over x. If the degrees end in a 5, it's a 45-degree angle. So I'm thinking cosine of 45 temporarily, radical 2 over 2. Remember, before this was radical 2 over 2, this was 1 over radical 2. So if you flip that, it means cosecant is just going, or secant and cosecant are just going to be radical 2. We talked about that in the beginning of the chapter. You can also just write that information. You can write whatever you want on your paper to help you out. Is it positive or negative? This is quadrant 2. Secant and therefore cosine are negative in quadrant 2. Cotangent is x over y. So at 0 radians, x over y is 1 over 0. Anytime you divide by 0, that's undefined. Not equal to 0, but undefined. Tangent of 30. So go to 30 degrees. We're doing y over x. So 30 degrees. Now, you could say, okay, it's 1/2 over radical 3 over 2, but all of these have denominators of 2, so the 2's are going to cancel out. You do not have to do this math every single time. What I really do is I just take the numerators. So at 30 degrees, the y numerator is 1, and the x numerator is radical 3, and then I'm going to rationalize that, radical 3 over 3. I have students sometimes that will do this work every single time, but the 2's always cancel out, so save yourself some writing and some work. Secant is the reciprocal of cosine, so 1 over x. It's got a pi over 3 in it. Okay, so just do cosine, just think what's cosine of pi over 3, and then we're going to flip it. So cosine of pi over 3 is 1/2, but we're flipping that to be 2. And then check positive or negative. This is in quadrant 4. 5 pi over 3 is down here. All right, so cosine is positive down there, and therefore secant is as well. Cosine of 11 pi over 6. So figure out cosine of pi over 6 first. Cosine of pi over 6 is the x-coordinate. It's radical 3 over 2. And 11 pi over 6 is over here in quadrant 4 again, where cosine's positive. Tangent of 120. So where's 120? 120 is this angle. So that's the 60-degree angle. The 60-degree angle is the one that's closest to the y-axis. The 30-degree angle is closest to the x-axis. So really treat this like tangent of 60. Figure out that answer. So tangent of 60, y over x at 60. I keep having to scroll, so I'm just going to make this smaller. There we go. So the tangent of 60 is radical 3, that numerator, over 1, that numerator. So it's radical 3. Should it be positive or negative? You're in quadrant 2. Only sign is positive, so this is negative, radical 3. Actually, instead of making this tiny, let's just drag it down to where I need it. That makes sense, doesn't it? Okay. Okay, sine of pi over 4. I love the pi over 4s. They're the easy ones. Sine is radical 2 over 2. Oops, my color changed. Cosecant of 120. So this is going to be 1 over the y-coordinate. 120, we already did that. If you like, by the way, you can rewrite the coordinates as you use them. This is negative 1/2 positive radical 3 over 2, if that makes it easier. So what's the cosecant of 120? So flip the y value, 2 over radical 3. Sine and cosecant are positive. So it's just positive 2 radical 3 over 3. Tangent of 7 pi over 6. So figure out tangent of pi over 6. Tangent of pi over 6 is y over x. So 1, that numerator, over radical 3, because the 2's would cancel out. That's radical 3 over 3. And then is it positive or negative? You're in quadrant 3 at 7 pi over 6. Tangent's positive. Cosine of 180 is the x-coordinate at 180, negative 1. Sine of pi over 2 is the y-coordinate at pi over 2, positive 1. Cotangent of 315, this ends in a 5, so that is the 45-degree angle. So think about the x over y at 45 degrees, really. The x over y is the same number divided by itself, so it's going to be 1. And you're in quadrant 4, where tangent and cotangent are negative. Secant is the reciprocal of the x-coordinate. So take a look at the pi over 6 angle. The x-coordinate is radical 3 over 2. So make this 2 over radical 3. And then this is in quadrant 3, so it's going to be negative. Finally, we need to rationalize that. Cosecant of pi, so this is 1 over the y-coordinate at pi. The y-coordinate is 0, so 1 over 0 is undefined. I know as we first do these, they are confusing, and it's sort of like, oh, there's so much to remember. Like I said, if you would like to draw more than just the first quadrant, remember, you should know the common angles, and to quickly get the other coordinates, you're just reflecting, like, I have the same 3 coordinates here. It's just that they're negative. So I could say, just reflect these across like this. It's just the main reason I don't write every single coordinate is because I don't want to make a silly mistake where I miswrite one, and I don't want to take the time to do it. Like, see, I just miswrote that one. It's positive 1/2. And you do run the risk of doing that because you're kind of like trying to rush to get all this done, and you're doing your whole circle. And so I like to just either fill it in as I go for the angles I need, or just do the first quadrant, kind of help yourself jump around. The first couple times we do these speed quizzes, it is a little bit stressful, and people are going, up to the 10 minutes or whatever. But that's okay. It will get better. And just like the factoring speed quizzes just became sort of like a nice way to pad your quiz grade, it's the same way with these. All right. So we will work on these once a week, every Friday, unless we need to change that day. And yeah, come into office hours to practice.